All right, we're back with more bullet hell and processing action. And what we're going to do now is, we have the long-awaited lesson where we're going to make it so that we can shoot bad guys. Right now, it's so unsatisfying when we go to shoot the bad guys and they don't even care that we're sprinkling them with our blue bullets. And, we want them to explode into all sorts of bits and pieces. So that's what we're going to do in a couple of minutes. So, first off, in our game object class, we're going to add in a new variable, the hit points variable. This hit points variable is going to then propagate to all the subclasses. Anything that extends it will also get hit points as well. Bullets, enemies, launchers, ships, and stars. You might question, do all of these things need hit points? But you know what? Enough of them need it that I don't really want to put it into each individual class. So we're going to give everything hit points, and if it doesn't need hit points, like stars, they're not going to explode or anything. Well, yeah, maybe they will, but probably they won't. We'll just ignore hit points altogether. So what we'll do, though, is we will bake it into the game object class, and then for things like the enemy class, in the constructor, we'll give it its initial value, like HP equals 10, or whatever number you want to give for your generic enemy. And then in the bullet class, I also gave my bullet an HP as well. That way we can destroy the bullet later on. So if you're going to do that for your enemy, then also you have to include HP into the has died function. That's the Boolean function that checks to see if this spaceship has died or not, the enemy spaceship. So, right now we blow them up after they go beyond the bottom of the screen. But we're also going to include an or condition as well. So either they go off the screen or their hit points are less than or equal to 0. That means this enemy has died. So we've included that as well. This is what gives HP meaning. It's not like the variable HP means something special in processing. It means something in games, usually, thanks Gary Gygax, who invented hit points and Dungeons and Dragons. But also, we have to give it meaning so the processing knows. I did the same thing in the bullet class as well. Check it out under its has died function. It also returns true if the HP is less than or equal to 0. That's what makes that mean something. That makes HP mean that we are dead when we get to 0 HP. So now we have to go and make it so that when we get hit by a bullet, we lose HP. So a bullet will first of all detect collisions with bullets, and then lower HP. That's going to be what we're going to do, and we're going to put that into the act function right in here. So there's a couple of concerns. So first of all, one concern is, well, what's the math behind checking to see if two rectangles have collided? The other concern is, which bullet are we colliding with, and how do we refer to those bullets? So if we just run the game for a second, if I have a stream of bullets coming out, there's all sorts of bullets for the enemy to be checking, and at any given point in time, it may or may not be colliding with any of them. So I guess each enemy has to go through all of the bullets that are on the screen, and each time apply the math that will check to see if they are colliding. So that's the story there. So let's go and look at how we're going to do that. So first of all, what's the math for figuring out if two rectangles are colliding? So we are going to hand wave this one a little bit. Here is the function, and this is available from jeffreythompson.org. It's written by a fellow named Jeff Thompson, who wrote this function and many other collision functions for processing for people to use for making their own projects. And it's not that we couldn't figure it out ourselves, I think. Given a full lesson on this topic, we could figure it out. But I'm going to leave it as an exercise for you students to read it over and see if you can make sense of it. Ultimately, we need to know how to use it. And we can do a lot of programming knowing the how to use it. That's one of the advantages of having things broken down into functions. I mean, for example, we don't really know the math involved in drawing the ellipse. I mean, there's all this anti-aliasing that goes on to make the edge look round and all this kind of stuff. And, yet we still can use ellipse just fine to make all sorts of cool programs. So by the same token, we're not as a class going to go over how this function works, but we are going to learn to use it. So thanks, Jeff Thompson, and feel free to go check out his website. It's full of awesome processing stuff and other things besides. So rect is the name of the function that's going to detect if two things are colliding. And what it does is it basically takes in 8 numbers. The first 4 numbers are the x, y, width, and height of one rectangle. And then the second set of 4 numbers are the x. Oh, I just can't seem to scroll over. The x, y, and width and height of a second rectangle. So that's what's going on there. So 8 numbers altogether, basically 2 sets of 4 numbers that describe rectangles. And it's you'll notice, a Boolean function. So it's going to return true or false. Are the rectangles defined by those 8 numbers colliding? So that's what we're gonna use to determine collisions. So that's that. So we'll take a look at an example of how to use rect. Well, let's see. We also have to solve the problem of excuse me. How do you know where all the bullets are? Because there could be 0 bullets on the screen. There could be 100 bullets on the screen. The enemy's going to look at every bullet that's currently on the screen, which may be as small as 0. So I'm just going to drink some water just a sec. So what we're going to do is we're going to write a loop that's going to go through our game engine array list and look at all the things in there and check for bullets. So this is something we've done already, actually. We've done something like that here. This is our, game engine code. We talked about this being sort of the core of our game engine. We go through the array list, we go through it backwards, and we have a while loop that goes through all of the things that are in the game engine and applies a show function, an act function, and then checks to see if they have died and possibly remove them. So there's this while loop. So we're going to do the same sort of thing. This is where it could get a little inefficient. So I don't want anyone to sort of think this is the perfect solution. There's definitely more efficient solutions that don't require us to look at every star and every enemy and all these things that aren't collision worthy with the spaceship. But it's going to be really simple, and it's going to turn out to not matter that much if it's a little wasteful in terms of what it's looking at, because our computers nowadays are strong enough not to care too much. So for the sake of simplicity, we're going to look through the entire game engine for anything that's a bullet and check collisions with that bullet. So here's how we do it. So first of all, we need the while loop. So we're going to start from the beginning of the array list. So that's index 0, and we'll use the letter I as the variable to represent our index. We're going to say, well, I is less than engine.size. So engine.size is how many things are in the engine. So in other words, we're going to start with index 0 and keep on going as long as we're not at the end of the array list. And each time we're going to do something. We're going to check for collisions, but we're going to do something. And at the end, we're going to go to the next index. So this will look through our entire array list of all the different things in our game engine and examine them. So how do we get something out of the game engine? Well, we use the get function. We can say engine.get I. So the I is, of course, the index. It's sort of like a street and a house number kind of concept. A mailman is trying to deliver a letter, so he's got to go to 123 Fake Street, right? So there's Fake Street, has many houses. They're all numbered differently. So index is how things in an array list are numbered. It starts with 0. So we're going to get, the first thing, and then the second thing, and the third thing, and the fourth thing, and so on. Get all the things. And each time we're just going to give it a name. Just a temporary name, just to refer to it in the rest of the code. So it's going to be a game object variable, and we'll just call it thing. It's a thing. We don't know what it is. It could be a star, it could be a bullet, it could be all sorts of things. So we'll get it. We'll get the thing, and then we can examine the thing with if statements. Just going to get another drink of water. So here's our if statement. First of all, we want to know if thing is a bullet. We don't want to check collisions with stars or other enemies. We want to check collisions with bullets. So here's the instance of operator. We'll say if thing, instance of bullet. So the way that instance of works is on this side you give it an object, and on the other side you give it a class, and it will be true if this object is from this class. If it's not a bullet, it's not gonna return true. So this will allow us to only look at bullets. So we want to look at bullets, but then the next thing is we only care about bullets that are intersecting us. So here's another if statement. This is where we use rect. So what we can do is we can say if rect, which means if these two rectangles are colliding, then we'll do something else. So the way you use rect again is you give it the 4 numbers. So it's x, y, width, and height. So that's the x, y, width, and height of the enemy, because we're in the enemy class, right? So x and y refers to enemy. And then because our enemies are drawn as 50-50, then I'll put that as 50-50. The next numbers are for the bullet. So for bullet, it'll be thing.x, thing.y, and then I don't know how big our bullets are. 5 by 5. So 5, 5. And that will be the bullet's coordinates and dimensions. So now we can say, if thing is a bullet, and if our spaceship and that thing are colliding, then we can hurt the enemy. We can have the enemy reduce its hit points by 1. And you can do whatever numbers you want. That just means it'll take 10 hits to blow up the enemy. Seems like it should work. Let's find out. It's always a little bit scary when we go do this. Let's find out. You never know. Could have made a mistake. Oops. Oh, no, they seem to be going away. That's pretty good. It seems to die awfully fast, right? We had 10 hit points, but the bullets just seem to tear it apart. The reason is because the bullets don't go away. So for every frame that they're touching the bad guy, then they are causing that damage to go through. Sometimes, I guess it's not enough. But that's a bit of a problem. That doesn't really give us satisfying game mechanics. So what we're also going to do is when we have that collision, we'll also set things HP, the bullet's HP, to 0. We'll just say, bullet, we're going to blow you up too. And that way it'll take many hits. So let's go ahead and run that. And let's see, does that work? Let's see if they impact on the surface. Yeah, they do. And it seems like it takes a bit more hits now. You actually have to. I mean, the rate of fire of this gun is ridiculous, so it's sort of hard to tell if it's balanced or not. But if I try to weaken it a bit, then you can see that it's probably 10 bullets that it's absorbing in terms of amount of damage. So there you go. So what's next? So we'd like to do something a little bit fancier. You guys are, probably sick of seeing rectangles and stuff. So as great as rectangles are, eventually we want to make this game look good. So here's one of the first things that's going to look good. It's also going to leverage the HP concept here. So we're going to create a new class. It's going to be little particles that will explode off of the spaceships when bullets collide with them. And what we're going to do is we're going to use their HP as sort of a timer to degrade them as they fly away from the spaceship. And they'll eventually sort of end up reducing their hit points to 0 by themselves, and therefore expire and be deleted from the engine. And we'll have them sort of spark off of collisions. So what we're going to do is we're going to make a new class. We'll make a tab for that. I'm going to call it particle. It's like an explosion piece, I guess. And I'm going to make this class particle. And yes, it's going to extend game object. And it's going to go into our engine just like everything else. Well, actually, not everything else. There are going to be some things in the future that don't. But, we'll get there. So a particle. Oh my goodness. It's going to be one of those obedient classes that just goes where it's told. So we're going to make some parameters for that. Here's incoming X, incoming Y. These are the numbers that we will send it when we create it. So it's just going to be obedient. It's just going to be told to go to whatever its incoming X is and whatever its incoming Y is. Eventually we'll send sort of the impact site of where that collision happens. What's this dx and dy? Well, they'll kind of fly off in random directions. So we'll just give it a random dx and dy. And hit points, we're going to make it 255 because that's the number, that's the highest range for opacity and color variables in general. Just one moment. We're going to be mapping the hit points to the opacity of these things so they'll fade away as they die out. So, what does a particle do? So, particles will show themselves. And they're just going to be an itty bitty rectangle. I don't know how big. I'll make it 5 by 5, I guess. And we're going to color them the same color as the spaceship. I'm not sure if it should be bullet or spaceship, but I'll do spaceship. Excuse me. And HP is going to be a second parameter to the fill function. When you give it 2 parameters, the second parameter acts as the opacity, which ranges from 0 to 255, which is 256 possible values for the opacity. So 255 is 100% solid. It's completely non-transparent. 0 is invisible because it's completely transparent. So as HP decreases, so will the transparency of our particles. We'll do a show function. I just did the same thing again. We'll do an act function. Act is just going to make the particles move. So we'll add dx and dy to x and y. And we'll also degrade our hit points. I'm not sure how fast to degrade them. It doesn't matter. One is probably too slow. We won't actually see it happen. So I'll go down by, I don't know, 2. You guys can decide what you want to do there. And then a has died function. And we'll do Boolean has died. And what we'll do is we will return if HP is less than or equal to 0. Because that means it's died. Hence, has died. Yeah, good times. So, that's great in terms of defining a particle class. So, these particles don't just show up on their own. Where are we going to make them? Well, we'll make them in the enemy class. This is the code that we just did that is all about collisions, right? So when we have a collision, that's this bit of code right here. We have found a bullet that is intersecting with our enemy, and this is the resulting code that happens. So what we can do is say engine.add new particle. And we'll send it this is where I don't really know what we should send it actually. We could send it the bullets X and Y, and then the sparks will come out from the impact site, or we could send it the enemy's X and Y. I'll just send it the bullets X and Y for no particular reason. So we'll run that, and we'll see what happens. I don't think I ran it. There we go. Okay, so we're looking for sparks flying off of collisions here. Hey, look at those sparks come off. And you can see that they sort of fly off into space and get smaller as they go. Oh, it looks like my kids are back from preschool. It's okay. You want to say hi to the students at school?
Hello.
Hello. Okay, you can go. I'm going to be teaching this lesson for a while longer, okay? Can you go out to the living room? Thank you, sweetie. It's okay. Oh, that's cute. Anyways, where was I? So we got the sparks coming off. That's good. We can probably do better. I like a little bit more variety in what's going on. So it might be nicer to have sort of a randomized hit points to start with. And we could start with, anywhere from 100 to 255. And that way there'll be a little bit of difference in terms of the brightness or the opacity of the different sparks as they come off. And I'd like to have a few more come off. We could be clever about that and write a loop. And you know what? If Control C and Control V were working on my MacBook Air, I'd probably be better off. So I'm not sure why I'm doing this, but I mean, you could just type in multiple ones of these to make as many as you wanted to. You can write a little loop. Hey, here's a loop for you. This is the best way to do it, to be honest. Here's a for loop. My gosh, we have a loop and a loop. I'm getting a little bit nervous. For loops we haven't talked about too much, but it's just a condensed while loop. We already have an I, so we'll make J. J is less than 5, we'll say. And this is the number of times this loop will run, is this number here, 5. J++, put in some things. And this, every time we have a bullet, collide, then we'll have 5 sparks come off because we say 5 times. So let's run that and just see what that looks like with our variety of particles and our collisions. Yeah, so some are kind of darker and some are not so dark and so on. So we get a little bit more variety going on. And we can sort of, I don't really see that they're coming off at different parts of the spaceship. But it's starting to look good, right? Like that effect is better than rectangles have been so far. And it's kind of neat that we have so many things going on in this game right now. Have you stopped to just think about the fact that we have all these bullets, all these enemies, all these particles, and we're, having loops that, within one frame, 1/60th of a second, we're going through all of them, telling them to show and act and checking if they've died. And every time we get to an enemy, it then goes through that whole list all over again and checks if any of those things are bullets, and then checks if they're colliding, and then goes into a loop to make 5 things. Like, this is a lot. So it's pretty amazing that this works as smoothly as it does, and there are ways to optimize this, but it works quite solidly. So we're going to kind of go with this and perhaps talk about optimizing it later on. So there we go. Thanks for listening to this episode, and we'll come back to you shortly.